So this is the second part to the antiderivatives video. So to start off, the theorem. If f of x is continuous on a and b, or if f of x is continuous with at most finitely many jump discontinuities, then f of x is integrable over a, b. So the integral from a to b of f of x dx is the signed area of region between the graph and the x-axis over a, b. So what the signed area of a region is the area above the x-axis minus the area below the x-axis. So visually here it is. If we were to take the integral of this graph, which we can call f of x, we get the signed region. So this would be negative because it's below the x-axis, and this part would all be positive. So that is why it's the area above the x-axis, which is all of this in here, minus the area of this, gives us our total. So the integral of a constant. This is pretty straightforward. The integral of a constant from a to b of a constant dx will equal c, the constant, times b minus a. And this is straightforward because if you look at this graph here of y equals a constant, it's just straight across. So if we want to find the area between a and b that it is above or below the x-axis, it comes out to just a perfect rectangle. Now this height here will be c. That is equal to c. So to find the area, it would be c multiplied by this length, which is b minus a. So this is what we get here. So linearity of a constant. If f and g are integrable over ab, then f plus g and constant times f are integrable. So here's just a couple of formulas that are used. So if the integral from a to b of f of x plus g of x can be split up into two integrals. It can be written as the integral of f of x plus the integral of g of x. When you have a constant in the matter, the integral of a to b of a constant times f of x, you can bring the constant out in front and actually evaluate the integral of f of x from a to b and then multiply it by c, the constant. And also reversing because you want to have the lower number on the bottom. So let's say that b is greater than a or a is less than b. If you have b on the bottom, for evaluating integral from b to a of f of x, you can flip the sign of it in front, put a negative, and then the a and b will flip. And a zero, it's when you're evaluating the integral from a to a or b to b, it's always equals 0. This can be shown because if we have a graph and we're trying to find the area from a to a, you actually haven't gone anywhere, so this area is going to be 0 because a minus a equals 0. So here's an example problem that I'm going to solve out. So evaluate the integral of sine 4x minus 9 plus 6 cos 8x dx. The derivative I just have over here written on the side. The derivative of sine kx plus b equals k times cos of kx plus b. And I also have the two integral formulas written out here. So first step is we can split this up into two parts. We can write this as the integral of sine 4x minus 9 dx plus the integral of 6 cos 8x. Next step, we notice that there is a constant here in front of the cos, so we can bring this out to the front. So this can now be written as sine 4x minus 9 dx plus 6 times the integral of cos 8x. Now we can evaluate by using both of these formulas. The integral of sine of something is going to be negative 1 over k, and in this case our k value is 4, negative a quarter. The integral, or the antiderivative of sine, is negative cos, so it's negative in front of the 1/4. Cos, and then what we had inside, so 4x minus 9, then plus, it's going to be the integral of cos 8x is going to be 1 over 8 sine multiplied by 6. So 6 times 1 over 8 sine 8x, and then plus c. 6 times 1 over 8 can be written as 6 over 8. So our final answer is negative 1/4 cos of 4x minus 9 plus 6 over 8. Oops. I guess we can write that as 3/4. 3 over 4 sine 8x plus c. And that is your final answer.